In this presentation, I will introduce linked list. So let's get started. Suppose you are given a set of numbers and you are told to store this number. So my question is how to maintain this list of numbers within the memory. In order to maintain list in a memory, there are two ways. One is called the array data structure, which has been discussed earlier. And there is an alternative way of storing this element which is called linked list, and it look like this. We have already dealt with array, so here we will deal with the linked list. An array has several limitations or disadvantages. All these are overcome by the linked list data structure. Before starting linked list, let me tell you or remind you about the disadvantages of array. The first one is the number of elements to be stored in an array should be known in advance. If it is not known to you, then you may face problem during runtime. Once declared, the size of the array cannot be modified. The memory which is allocated to it cannot be increased or decreased. And for that, array is called a static data structure. Next, time complexity increases in insertion and deletion operation. So if you want to add some numbers within this array, there may be a physical shifting of numbers within the array. So it takes time. Next, it stores homogeneous types of data. If the array is declared as int, then you can store only integer value within that array. It is not possible to store any other data type in an integer array. All these disadvantages can be resolved by using linked list. Now let me tell you the types of linked list available. The first one is the singly linked list. In a singly linked list, only the forward traversal or the navigation is possible. That means we can access data from the start position and then move on to a single direction. Reverse traversing is not possible. Next, doubly linked list. In a doubly linked list, there is a possibility of two-way traversal. That means you can go forward or move backward from any node. That is why it is called doubly linked list. And the last one is the circular linked list. In case of circular linked list, the last element point to the first element. That means after visiting 50, you can again go back to the first node, that is 10. And I think you have noticed that in case of singly linked list and doubly linked list, the last two element points to the null. That means this is the end of the linked list. In this video, let me tell you about the singly linked list. So what is singly linked list? A singly linked list or a one-way list is a linear collection of data elements called nodes, where the linear order is given by means of pointer. Now, if you ask me what is a singly linked list in a simple way, I will tell you that a singly linked list is made up of nodes. So what is nodes? You have to know about the node first. This is a node. A node is a block of memory which is reserved or allocated within the memory. This block of memory is divided into two parts. One is called the data part and another is called the link part. The data part contains the information. For the simplicity, I am showing you a single data part. A node can have more than one data part. For the time being, just consider that a node has a single data part. And the other part contains the link part, which means that it contains the address of the next node. Since a linked list contains several nodes, so each of the node requires to hold the address of the another node. For that, we use the link part. Now let me show you how the singly linked list is represented. So this is what you call the representation of a singly linked list. Suppose we want to store 10, 20, 30, 40 in a singly linked list. For this, we require 4 separate nodes. The data part of each node contains 10, 20, 30 and 40 respectively. It is not necessary to reside all the nodes sequentially or in a contiguous memory location. Each of the nodes occupy a range of addresses within the memory. So for the simplicity, we will consider only the first address of the node. So the address of the nodes are 1000, 2000, 3000 and 4000. That means 1000 is the starting address of the first node. 2000 is the starting address of the second node and so on. I have written the address arbitrarily. Now suppose the link part of the first node stored the address of the second node, that is 2000, and it signifies that the first node is now pointing to the second node. Again, the link part of the second node stores the address of the third node, that is 3000. That's mean it is pointing to the third node. Similarly, the link part of the third nodes contains the address of the fourth node, which means that the third node is pointing to the fourth node. Since no other node after 40, so the link part of the fourth node will be null. And this null represents the end of the list, that is, no other node is present after the fourth node. So this is what we called a linked list. You can also say that the individual element are stored somewhere in the memory rather than like a family dispersed, but still bound together. So this bound is done by storing the address of the next node. Now, to access this list, you need a pointer variable which will point to the first node, that is 10, and whose address is 1000. So you require a pointer variable. Suppose I am writing over here as a start pointer variable. You can also write head or beginning in place of start. So it's just a name. So you can give any name in place of start. Since this is the starting of the list, so I have written start over here. So this start pointer will hold the address of the first node, that is the 1000, which means that the start is pointing to the first node. So whenever you want to access this list, you have to start from the beginning, that is 1000. So by looking into the start pointer variable, you can reach to the first node, that is 10, and the link part of the first node, which is 2000, and by looking into this 2000, you can reach to the second node. The link part of the second node contains 3000, which is the address of the third node, and by using this address, you can reach to the third node, and so on. So when it gets a null in the link part of a node, it will stop traversing. Next, what are the advantages of linked list? The first one is dynamic data structure. That means the size of the linked list can grow and shrink at runtime by allocating and deallocating memory. So there is no need to give an initial size of the linked list. Then extensive manipulation of stored data. Programs in these areas require the operations such as insertion and deletion to perform frequent operation on the data. Unlike array, here we do not have to shift element after insertion or deletion of an element. In linked list, we just have to update the address present in the next pointer of a node. Then no memory wastage. As the linked list increase or decrease at runtime, so there is no memory wastage. So this linked list can be readjusted according to the user's choice. Unlike array, you do not have to specify a particular size at the beginning. Still, single linked list has some disadvantages. So the disadvantages of linked list are: memory usage is large as compared to array, because linked list requires more memory space than the array for storing the same number of elements, as it also stores the next memory address. Then no random traversal. That's mean if you want to access any particular node within the linked list, so you have to traverse all the nodes before the destination node. In case of array, you can access any memory location with the help of array index, and it is not possible in case of single linked list, or rather in any type of linked list. So to reach to a destination, you have to start from the beginning, you have to traverse all the nodes, and then you have to reach the destination. And finally, no backward traversal in case of singly linked list. That's mean revert traversing is not possible. Why? Since each link of the node points to the next node, so we can navigate forward direction only. So here is no possibility to move backward. So if we want to go backward, so again we have to start from the beginning and move to a particular node. But this limitation has been solved in case of doubly linked list. This is all for this video. In the next video, I will show you how to construct or create the node by using program. Thank you.